This conference will now be recorded.
Yeah. So, hello all, and welcome to officially the day one of the series. So, yesterday was more sort of like an overview, right? So, today we'll be starting with our sessions and with the modules. So, in today's sessions, our main agenda will be to understand what is chaos engineering in a little bit detail, to understand the fundamentals, and also we will try to set up Gremlin on a basic like a basic how you run a basic attack using Gremlin. We will see that. Okay. So
Your voice is very low. Is it only for me or for others also facing the same issue?
is it too low?
Yes,
Okay. Let me check out. Is it okay now?
little better.
Better?
It's fine for me.
Mm,
It's very normal.
uh,
It's very
okay. Yeah. Priyanka, so can you try to increase your speaker sound or maybe earphone?
Yeah, I'll do that. If it is only for me, then it is fine.
No, it doesn't. It's not that it might totally be only for you, but maybe uh, yeah, I guess. Yeah, right. So, but let me know, okay, if I'm very feeble, like if my voice is very feeble and you're not able to hear. Okay. Okay. So, in now when we speak about chaos engineering, mainly the rise of chaos engineering, when we speak on that topic, right? How many of you are aware about what are distributed systems? Anyone? When we say distributed system, what do you mean by that? Anyone? So, what are distributed systems? Just give it a shot, okay? Let's keep the sessions interactive so that we don't get sleepy. It's again evening time, right? So even like you can keep yourself unmuted also, if less background noise. You can keep speaking. You can keep asking questions to me, okay? So be free. Any questions, like well, let it be even a foolish question. I don't. It doesn't matter. Question is a question, right? We are all here to learn. So yeah, go ahead. So what do we mean by distributed systems? Anyone?
basically
Uh,
Maybe our
yeah.
application is deployed into multiple servers.
Uh, okay. So any other answers? Priyanka, Shraddha. So what do we mean by distributed systems?
uh, in extent to the same answer, deployed on multiple
Yeah.
servers, also across different regions.
Okay. Yeah. Okay. So let's discuss that in little detail. Okay, because that is very important nowadays. The systems, whatever you'll see, out of that 60 to 70% are already onto distributed systems, right? So we need to understand what they are. Okay. So see, let's say I have an application, some xyz.com. Okay, which was like, let's say, in the time when some 2000s, okay, around 2001 and all. Okay, that application was there. Let's say there's one another application which is x, maybe x some z.com. Okay, and this is in like 2000s, maybe after 10s and all, some 2010 after plus 15 plus. Okay, now the difference, see what happened was when we were developing an application in the 2000s. Okay, things were far more different. So there, let's say Priyanka and Muthu are two developers. Okay, we have Priyanka and Muthu. Now Muthu is developing order, and Priyanka actually is working on, let's say, login. Okay, and let's say Nagaraj, he's working on a functionality of payments. Now my question to all of you is, uh, without login, will order work? Anyone?
No.
Without login, will order work?
No.
No. Okay, generally, no application will accept the orders without login. Okay. Now, without that order checkout step, will payments work?
Obviously
Will it
no.
work? Sorry.
No.
No, it will not work, right? So, unless Priyanka, she hasn't finished developing whatever she is going to develop, Muthu will be waiting. Okay, unless Muthu hasn't developed what he is going to develop, Nagaraj will be waiting, right? So that problem here is the dependency. That word is very important. Okay, the dependency. So what used to happen is such type of system, or like where Muthu will be working only on order, or Nagaraj will be working only on payments, Priyanka will be working only on login. That system was not there before. Okay, so basically all three will work on all the products. That's how the things used to happen, development. Okay, but that led to different problems. Okay, so now the solution to this is we needed to remove that dependency. Okay, so how did we remove the dependency? Okay, so let's say I have order, I have payments, I have accounts, okay, and let's say I have catalog. So let's say these are the four different categories of functions I have. Okay, I'm just categorizing those functions. Now this order, as I said, the accounts has to be developed first. Let's say catalog second, order third, and payment fourth. So that's how the system has to be developed in the earlier, like when there was no distributed systems. Okay, so what we did now is to solve this problem, we separated each one of them, and we defined a common language between, like it's more sort of you are connecting each of them through a language. Okay, and we called that as an API. Okay, so now what happened was, so let's say I have account, I have order, I have payment, I have catalog. Okay, now account, so what this order or account or payment or catalog, let's say these are four teams, okay, who are working on each of these things. Now order knows that there is an accounts API that will be my input. Okay, similarly payment knows there will be order API that will be my input. Catalog knows, let's say it has account, order, or whatever. Okay, based on that it knows the API. So now what happened was, since I know that this accounts API, whatever, like somebody, okay, so let's say there will be username, there will be password, there will be some session ID. So this will be what I will get from accounts. The order knows. Now, does order needs to wait for accounts to complete, or it can start developing?
It can start because there is no
Yes.
dependent.
Right. So now the order knows, okay, this is what is going to come. So what it will do, it will just for now, unless the accounts is fully developed, it will keep some mock or SV, right? Mock or SV means like what I can say is for those who are new to that words, it's more sort of like accounts doesn't exist, but we just keep it as a dummy. Okay, whatever the basically some dummy system where these APIs will come. Okay, but that account will not be ready, but once account is ready, the dummy will go and the real system will come. Okay, so ultimately what happened here is the dependency of development went away. Now do you think the development became faster? Do you think, did development become faster?
Yes.
Yes. And now with this, whatever the account is built on, let's say it's C programming or it's on some different system. Now order is, should the order be also on C, or can order be on some other language with
It
this
can be
setup?
some other language.
Yes, it can be some other language because all these, like let's say Nagaraj is from, let's say Nagaraj knows Tamil, Priyanka knows Telugu, and let's say Muthu knows Hindi. Okay, now let's say Priyanka, Muthu, Nagaraj, they three want to speak with each other. So they, like Nagaraj doesn't need to know Hindi to speak to Muthu. Nagaraj doesn't need to know Telugu to speak to Priyanka, because all these three people have a common language, which is English. Let's say. Similarly, this all these have a common language. What is that language? All these four, the API, right?
API.
Right. So that API language is what they all four need to know. Otherwise, whatever they know individually or what they are doing individually doesn't matter. So they can be on different languages, they can be on different systems, they can be of different architecture. Like for example, accounts can use DynamoDB, order can use MySQL DB. So such variations are possible. So first is development became faster. Second is technology adoption became faster. Third is expertise. Now let's say order team is expert in Java, accounts team is expert in some other language. Now they can apply that specific expertise to their service based on their expertise, right? So that made the systems more the systems became more excellent, right? Because each team, whatever their expertise were there, they applied it. But now my question to all of you is, everything looks good here, right? Like every development became faster, technology adoption became faster, the systems became more better. Okay, but what is the problem with this? Like, what are the problems you see with this? The systems became more complex. Did it become complex or not?
Yes.
So, as an individual, like account, order, payment, catalog, it became simpler. But when you see it as a holistic way, the full thing, right, it became complex. And that's why we call such systems as complex. And now each service or each functions are distributed. So distribution can be code or infrastructure, both. Okay.
But but earlier it was more complex, right?
So
Now
see
it is
here,
simpler.
yeah, right. No, so yeah, let me answer that question. Okay. So earlier, if you see, let's say you are developing login with let's say Java. You used to develop order also with Java, payment also with Java. There's no other way, because they all used to call with the same objects, same classes, same functions, right? But here the problem is each of them you are developing in different language. So as a tester, do you think is it easy to test? Because accounts is in different language, order in different language, payment in different language, it's okay. Anyways, so that's one part, but even the infrastructure is also different. One is in DynamoDB, one is in MySQL DB, one is in Oracle DB. So are you getting the point? How it became complex?
But at the
Hmm.
end, like, okay, okay, you are talking like previous
Hmm.
like architecture or current modern architecture.
Yeah, so current modern architectures are complex, right?
Okay,
And whatever we have, we were having traditionally, like let's say down the line 10-15 years back or 10 years back, so they were not that complex because the systems, the infrastructure wise or the server wise, they were not that complex. But now the things is like the development has become faster, things have become faster, but the systems have become complex. And this is
okay.
what I said yesterday also in our session, right? For example, let's say individually we all are perfect, but when we come in a group, do you think that group will be perfect? Anyone?
Mm,
So, see, what I'm saying is,
may or may
uh,
not.
right. So we might not see, for example, Nagra, let's say, we have, like say Priyanka and Shraddha, right? They might be very good friends, but let's say might be Nagraj and Muthu might not go together well. Just I'm just calling out some names. So what I'm saying is, it's all based on when you are coming together or when the systems are coming together, they will create problems. And that's where the complexity, that word, comes into picture. Clear? Any doubts? Okay, so
Yes.
such types of systems are called complex distributed systems. And these things, what you're seeing, right, the account, order, payments, catalog, these things we give a name called, generally now, if again with the advent of cloud and Kubernetes and all, we call it microservices. Okay, so microservices are nothing but they are independent with from each other. Okay, so order is independent from account, account is independent from payment, and they just communicate with each other with some APIs or some interface languages. That's all. Clear, everyone? Why we say microservices are independent? Any doubts? Okay, so yeah, so now you would have got an understanding what is complex distributed systems, and are you also able to imagine why the complex distributed systems led to rise of chaos engineering? Anyone? What could be the reason? Go ahead. Yeah. Okay. So see, let's say you have a system with so many complexity. So obviously, if the complexity has increased, the traditional testing practices, what we are doing, there were some gray areas which those testing practices couldn't uncover, right? So that's why we needed one more testing practice which could uncover those gray areas which came due to that complexities, right? And it's also like a vaccine. Vaccine means like, uh, it's more about prevention, or we can say a precaution, before, or not like a cure, right? Like for example, before the problem happens itself, we need to be ready for that problem rather than the problem happens and we solve it. No, we don't want that. We are like a vaccine where what we will do is we will simulate the issue, or means like we will just simulate the virus and create the solution to that problem. And when that real virus comes, we'll be ready for that. Same thing happens in chaos engineering also, right? We inject the failure, we try to study that, and then we solve it. Okay, so now coming to the main question, what is chaos engineering, right? So yesterday we had seen, so let's say a system is failing. Okay, Now, when a system is failing, two things can happen. One is, I'm just assuming system is failing. Okay, so it's not like system is not failing. It's failing. One is it will recover properly without any human intervention and all automatically. Second is it will not recover. So as per you, which is the proper scenario? Like I mean, which is good, which is a good application? First one or second one? A or B?
First one, recovering properly.
Yes, right. So A is a proper application, or I can say an ideal application, because though it failed, that's fine. It recovered properly, right? The one which is not recovering is a big problem, because then we need a human intervention. We might have to roll back the system, then put it into production, spin it up fast, which is a big process, right? Now, now let's take the assumption, take this recovering properly. Now a system is there which is recovering in 1 hour. Okay, and there is one system which is recovering in 5 minutes. Which is better, B or C?
It's B.
Yes, right. So whichever is recovering faster is better, right? I mean, like it's again dependent on what application you are using and all. But anyways, when we compare B to C, yes, B is better, right? Now, so chaos engineering, in very simple words, if you see, is all about how fast your system recovers from any failure. Okay, so see, let's say this is how clearly chaos engineering you can differentiate from other testings, like even failover testing. So in failover, what happens is even there is no point of recovery there. Like their main objective is not recovery. Their main objective is about withstand, right? That application has to withstand the failure. But here in chaos engineering, we don't say our application will withstand a failure, right? This application can fail. It's okay. It's not an ideal world. It can fail. But once it fails, it has to come up automatically in in faster way, right? So that is all about chaos engineering. How fast your systems recover from any failure. Any doubts, anyone? I can see some. Uh, Muthu, you have some doubt? Yeah,
Can others go into mute? We have some disturbance, background noise coming up.
yeah, that's fine. Yeah, Magesh, you had some doubt? You went on mute.
Yeah, yeah. I mean,
Yeah.
I didn't hear properly that what is the basic difference between this chaos testing and the failover testing?
Yeah. So see, now when we got two keywords, okay, one this recover. So in failover testing, it's about withstand. In chaos engineering, it's more about recovery. Okay. So if you see, it's a very close difference, right? We are injecting failure in both the cases. In failure also we are injecting failure, in chaos engineering also we are injecting failure. But in chaos engineering, the main objective what we are looking for is the recovery. How fast your system is able to recover from that failure, and how's your system reaction, the responses, those things what we are more worried about. In failover, it's more about withstanding, right? If some failure is injected, is my system like is my system able to withstand that failure or not, right? So in chaos engineering, it's more about recovery, and obviously the second one is the user experience. So how my user is getting affected from that event, right? Is it some so basically ultimately my goal is the user experience has to be kept intact even during that failure or that recovery period. Okay, so as I said, first main motive of a chaos engineer is recovery. Second is user experience. So initially, when you start your journey, you'll be more worried about the recovery, and as you progress in your chaos engineering domain, you will come into user experience also.
Okay.
Any doubts? Anyone? Anything else? So are you clear now? A clear difference between what is chaos engineering and what is not? Anyone has any doubts? Okay. So now before I go to further theory, okay, let me do one thing. So I will be just showing you something on Gremlin, okay? How to run a basic attack in Gremlin. Some steps I am not showing now because we will have to come back to this, okay? But just I want all you to understand or you get a basic feel of how the attacks are done, okay, using Gremlin. So for that, I thought I will show you a small demo. So let's try to.
Sir, I mean, what kind of attacks, as part of that chaos engineering are there? So one is like, I mean, we were forcibly making the nodes down like that, where they right, like that, such that how many types of techniques.
Mukesh, sorry, your voice is too low.
You said you are going to show one experiment, right? So, what? How many types of experiments are there in chaos
Yeah, there are a
engineering?
lot of types of experiments, around 12 to the. So what we will, and so it's also based on the tool. Like for Chaos Mesh, there are more experiments than Gremlin, right? But if you see, 12 are the most common ones and most what we can say major ones, which you will generally do in your project. Okay. So today we'll see one basic experiment to see the impact of that on especially who are new to Gremlin and all, they will get an idea, okay, because I just want to use this demo session so that you all if at all like you are maybe like later on if you are not there also you will get an idea what is happening, right? So in the chaos engineering and how it happens, even the AWS side also we are using AWS now, so just you will get an understanding how what happens in AWS, how some basics of AWS. Yeah, so now I am into AWS. So this is how the dashboard looks like when you get into AWS initially. So you will land onto this main page. Okay. So now as soon as you land onto this page, just search for EC2. Basically, EC2 is the compute engine or a compute resource, or we can say VM on cloud in AWS. Okay. So select that. Now here, if you will see an option called launch instance. Okay, click on that. Now here I'll give a name chaos demo. Okay, and here let's choose an Ubuntu machine, and you can choose the version of Ubuntu what you're going to use. Then after that, if you scroll down, you will get a section where you choose the instance type. Okay, just keep it T2 micro only. Don't change it. There are different instances which you can choose. Now, if you see T2 Nano and T2 Micro, what is the major difference you see in both of them? Is anyone able to observe the difference between T2 Micro and T2 Nano machines? So, what's the difference? Are you seeing any change in the memory here? Am I audible? I think,
Yes, yes, Vishnu.
yeah. So are you seeing any difference in the memory in both of those machines?
Yes.
So see, that is how you choose a machine in cloud, right? So what is the difference between then? I meant like uh, I can choose any machine, right? So what's the difference between choosing a machine? Like why do I need to choose a correct machine, nano or micro? What is that thing which will change when I change the machine? Are you seeing some USD per hour also below that? Everyone, are you seeing dollar per hour?
So we have to pay for what we choose.
Yes, exactly. Okay. So higher the resources you are choosing, higher the cost associated with it. So you have to choose based on your requirement. Similarly, in your application also when you are doing, what we need to understand is we will be choosing as per our requirement, not more, not less. So that's how the cloud works. So if you are choosing a higher value, you will get that higher also. But the problem is you have to pay a higher price, right? So let's choose T2 micro for now and keep pair. Let me keep the same. I will choose one which I already have created. You can create a new key pair, okay, in your case, if you're logging for the first time into AWS. Now here, if you scroll down, select this both HTTP and HTTPS traffic. Just click select allow, okay, and then the other things you can keep default and click on launch instance. So again, just giving a recap, I gave the name first, then I choose the Ubuntu image or the operating system what I'm going to run. Then I chose the instance type as T2 micro. Then the key pair, you can create a new key pair or you can use one which you already have. So basically using this only you will be logging in into this machine. Okay. So for that we need this. Then scroll down, create security group, select allow for all the things, and then storage you give like basically that you can keep the default value for now and click launch instance.
So what is it key pair? Like, is it username or something like that that you have given?
It's a public key, right? Like private key and public key. So using that, I will show you how we use that. Okay.
Oh,
Yeah. So let it come up. Okay. So currently the instance state it is showing pending. So it will come. Okay. So let's wait. Yeah, now it's in running state. So let's try to access this machine. So I will copy this public IP address. Okay, there are two, private and public. So copy the public. Open a software called Putty, which you can download from online. Just search Putty and click on download Putty, and you can click download Putty. Okay, and from here you can download, let's say 64-bit one here. Okay, just you can, I will just copy the link address and paste it in the chat for those who want it. Okay, once you have installed it, just download and install it. You can open Putty, just search Putty. Now the IP address which we copied, right, just press, just a minute, Control V and paste it here, that IP address. Okay, okay, similarly, in if you go to connection, click on SSH and click on auth, click on credentials. You have to choose the path to that ppk file. So this is where Priyanka you asked, right, that key, you need to choose that file here.
okay, got it.
Yeah, when you are generating a new key pair, that file will get downloaded automatically, okay, to your machine. Now in my case, I choose which is already I have downloaded. Okay. Now click on open, click accept and give Ubuntu, which is like standard login as, okay, when you do it for the first time. Click select Ubuntu and just give enter. Okay, it is saying, okay, so let's go back. Maybe that authentication path would have changed. So give putty again, open putty. So let me add the auth first. Shells browse. So let's browse the authentication. And session, I'll give the IP address and click open and give Ubuntu. Yes, now we are inside that machine. So whatever terminal now you are seeing here, actually I'm accessing that machine which I created now. Clear everyone till now what I did? So do I have only this terminal or do I have a GUI also? So see, my question is, now this machine what I'm accessing, is it different from my laptop? Is there any difference? Because this I am asking why, so that you understand there is no much difference between cloud and non-cloud. So cloud also, the machine is physical only. Is that part clear, all of you? See, when I say cloud, what do you think? Like, what do we mean by cloud? Let's say when I say a machine is in cloud, what do we mean by that? Is it a group of physical CPUs sitting somewhere and I'm accessing it through a network, or you think something else? What is it? Either evening time everyone is sleepy, or maybe the questions are little.
I
So
mean,
what
we
is the
will be
reason?
accessing the servers that are on cloud, like we can access uh,
Yeah,
by sitting at
exactly.
home.
Okay, so that's what we are doing here, right? We are accessing that server which we created. Now what we will do is, onto this we will deploy a this is a host, right? So to attack this host, I will deploy my Gremlin agent onto this in a very simple way. Okay, so for that I'll open Gremlin. So when you open Gremlin for the first time, okay, or the dashboard, you will see one quick start guide where we get different options to install the Gremlin agent. Okay. So now in our case, we are installing it for a host. Okay. So, and our host is a Ubuntu, right? Ubuntu machine. So we will use that. So run first this one. What we are doing is we are adding the Gremlin packages onto our machine. Now these commands you will find in my drive also, the drive link which I will share with you all. So there is one file called commands. In that you will see all the commands which we are using. Okay, which we will go through. Okay, when we as we progress in our course. Now today I just wanted to show you, okay, so that you understand all these things we will go again little in depth. Okay, so I'm just installing the Gremlin agent quickly onto that host. So currently that Gremlin is getting installed, okay, onto that machine. Now, see, now the installation is complete. Now, next step I need to do is I need to initialize that agent. Okay. So how do I initialize that agent? So let me switch to team. I will generate one. So I will just go to the account settings, sorry, team settings, and there, from there, I will just quickly pick up the team ID. And here I need to initialize the agent. Okay, so I will do gremlin init. Okay, first I have to put the team ID. I'll put that. Now next I need to put the team secret. Okay, so I just reset it for now. I'll copy the secret. Let me put it somewhere. So this is my secret. I'll paste that. So if you paste it wrong, right, the secret, it will not take. So we need to be very careful when we copy and paste the secret. So copy the ID, paste it, and secret we need to copy and paste it. Just a second, it is not picking. Just I'm checking why. Yeah, we are getting one peculiar error. Let us see why that error is coming. just I meant creating a manual Gremlin configuration file. I'll explain you all this, okay, what I'm doing. Yeah, so now it's done. So see, the problem was with the access. Now we were a normal user. Okay, so normal user, we needed little bit like the file access to the file which we needed. So what I did is I went root. So as an admin, I ran the Gremlin initialization. So it was because it was not able to access the Gremlin configuration file. Okay, so that's what we were getting the permission denied. So now see, we were able to configure the Gremlin agent. Now if I go back to my Gremlin and click on agents, so are you able to see one agent now in the agents?
Yes,
And this IP address, it will match with, if I go to my AWS,
server IP address. Yeah,
yes,
AWS IP address.
see the private IP, right? It will match with the private IP. Okay, so now let's try to see if we are able to run some experiment. So click on run experiment. And I will just run one basic experiment on this, so to just check if our agent is working properly or not. So let's say I run a CPU attack, and let it run for 1 minute, and let's make the CPU to 50% capacity. Core, I will give all cores. Okay, and I will click on run experiment. Now if I go to my system again, I enter top. So are you able to see what's the CPU utilization now? What is it now? What's the percentage CPU utilization?
It's 49, around 50.
Yeah, around 50, right? And if you see, what was the percentage I gave in Gremlin during the attack? Capacity
50%.
50%. So my agent is working properly, and I am able to inject a CPU failure onto my system using the Gremlin tool, right? So that's what we are able to see now. So see, now the CPU can spike under different conditions. What are the conditions where you will observe CPU spikes? Can you call out few?
When there is more traffic on application.
Yeah, when there is more traffic. And can it be like more traffic? Let's say it's a common thing. Can it be like this, like when you are having a very heavy logical operation which is happening? Can the CPU
Yes,
spike?
yes.
Yes, right? Yes. So CPU will spike in those situations also. So we need to study the system when such situations happen. So for that, we inject a failure where a CPU failure or something, and we try to see if the auto scaling is working properly, if the different configurations, if my application is able to take that sudden spike or not, and all those we try to study, and we will see how we create the report observation, how we what all we observe, how we try to analyze that, all those things in the upcoming sessions. Okay. Anyways, this was just like I wanted to show you quickly so that you get a feel of what happens. Okay, how you run an experiment, but it's just a tip of the iceberg. There are a lot of things to learn in the main process. Even while we deployed the agent also, I didn't go through each and everything. There are different processes of deploying agent, and each one has its own significance. Okay. Now if you see my after my attack, automatically my CPU utilization has come down to normal, right? So yeah, we will discuss all this. So see, the system, once you inject the failure, once you remove the failure, the system should come back to normal. Is that also a resiliency behavior or not?
Yes.
Right. Yes. So that also is a very important thing, right? You inject a failure, and if the system gets stuck in that whatever the failure mode was, so that is also showing that your system is not resilient. There is some problem with your system because it's not able to change the state, right? So yeah, there are a lot of things in that. We will see one by one. Once we run the attacks, we will see what are the different types of attacks, where we run these, how to set up all those, yeah, and in the main process, how to debug, analyze the systems, and all those we will see. Okay. Mm. Any questions,
So,
anyone?
Vishnu, yeah, Vishnu, I have a question. So, I'm completely new to this gremlin. So, I want to know like how it was spiking to 50% when we are giving that values.
Yeah. So already you know the answer. So CPU utilization actually gets affected from the logical operations, right? So what Gremlin agent will do is it will run some heavy logical operations in the background, which will take your CPU utilization to whatever value you give. But that's just in one line I'm explaining. When we go to further sessions, you will see that in depth. Okay, how it happens. Now due to time constraints, and also it's a high jump to go there now. But yeah, in a high level way, this is what Gremlin does.
Sure, sure, got it. Thanks.
Yeah.
Vishnu, I have a question.
Yeah, Nagaraj.
So from where do we draw these the baselines like 50% or something? So is it from the production log we take it from the past
Mhm.
failures,
So see,
our
it's all based on
experiences?
what you are testing. In a high level way, I will explain you, but in upcoming sessions, it will be more clear to you. But in high level way, see, let's say your main objective is now to test the auto scaling setup what you have. Now in that case, you already know what's the percentage. So the percentage will be the threshold, right? The auto scaling threshold which you have for the CPU or memory that you have set up in the configuration. So similar to what you are going to do, what's your objective, the values will change. Clear, Nagraj?
Yeah, yeah, clear.
Yeah. Okay. Yeah. Okay. So it's almost time today. So yeah, thank you all for joining, and let's meet tomorrow with a new session. So tomorrow we will come back to more basics on chaos engineering. We will see again few experiments, how it's done, and what are its impact, different attacks, how they help us in like excavating newer issues, right? So we will learn all those in this process. And yeah, so let's meet tomorrow, everyone. Thank you all, and have a good day and good night.
Thank you, Vishnu. Bye.